about combining sets. So basically we have a set made up of two or more parts that can't easily be combined into one form. So not everything can be listed out as individual values. Not everything can necessarily be put into an inequality. It's not one single interval. Then we would have different pieces and we would use this set union symbol between the different pieces. So that looks like a capital letter U. It's not. It's a separate symbol. Now for handwriting, it doesn't matter. But when you're entering into MATLAB, if you type a capital letter U, it'll have absolutely no idea what you're talking about. So you need to either choose the symbol on the toolbar, or if you like shortcuts, you can type \cup to get that symbol inserted. So this is typically used to combine multiple intervals, or occasionally combining an interval with one or more isolated points or distinct points. So some examples, if I have the set, reading this notation, the set of all x such that x equals 4, or 7 is less than x is less than 10. So just throwing that on a graph here. So here's 4, that's an isolated point. It's just, it can equal 4. And then over here we have 5, 6, and then we have 7, 8, 9, 10, and everything between those is included. The 7 and the 10 themselves aren't, so parentheses there. So we have this set that has these two pieces. So we have the isolated point that would typically just be stuck inside of the curly braces in set roster notation. Then we have the interval from 7 to 10 that would be written with the parentheses on either side of the 7, 10. To combine those two pieces, we just stick that union symbol in between. So we have the curly braces around the 4, and then the union symbol, and then the parentheses 7, 10 parentheses. We still go left to right as far as which order we put the pieces in. And then just the union symbol in between each, anywhere there's a gap, basically. Then another example, the set of all x such that x is less than 2, or x is greater than or equal to 4. So this is those two opposite rays that don't overlap. So it's not, it can't be written as a combined interval or a single combined inequality or interval. We have 2, 3, 4, so less than 2. So we have that piece pointing to the left, and then greater than or equal to 4. So square bracket on 4 and the arrow pointing to the right with a gap in between. When there's a gap, there's going to be the union symbol. So we have those two intervals going from -infinity to 2, and then from 4 to infinity with that union sign in between them. So let's look at some other practice here. So here we have sounds like a complicated set described here. It's a set containing the numbers 1, 2, 3, 4, 5, and 6. And it has all real numbers between 1 and 2, between 4 and 5, and between 5 and 6. Let's put that on a graph and see what's actually going on here. So we have 1, 2, 3, 4, 5, 6, and I'm just going to put a dot on each of those because those numbers are all included. And then we have everything between 1 and 2. So we have that interval, and then everything between 4 and 5, and everything between 5 and 6. Now looking at this, then what we basically have is the dots on each end of the interval just mean that's going to be a square bracket versus a parentheses. So we don't have to list those endpoints separately. They're going to be included in the interval. So square brackets 1, 2, square bracket. The 3 is just by itself still. So we have a gap between the 2 and the 3 that's not included. Then we would just put curly braces around the 3. And then we have another gap between the 3 and the 4. Now the 4, 5, and 6 are all included in this interval. So we have the square brackets 4, 6 square brackets, and that includes 4, 5, 6, and everything between 4 and 5, and everything between 5 and 6. All in that notation. So this would be the combined notation for that whole set. And then next example, we have some notation given of the set, and we want to figure out whether some of these numbers are or aren't in the set. So we have an interval from 7 to 9, and then we have the curly braces 10 to 12. So on a graph, we have 7, 8, 9, 10, 11, 12. We have everything between 7 and 9 from that interval notation. The parentheses means 7 itself is not included. Square bracket on 9, so 9 is included. Then the 10, 12 in the curly braces just means those individual values 10 and 12. So looking at the graph then, we can pretty easily, if you understand what the parts of the graph mean, tell 7 is not included in that set. 8 is, so 7 is not because it's parentheses on there. 8 is, it's in the middle of the everything between 7 and 9. 9 is because it had square brackets. 10 is because it was listed in the set roster. 11 is not because the set roster doesn't include anything other than the actual values that are listed. 12 is because it was in the set roster. So just be a little careful and understand the difference between what those curly braces mean if there's multiple numbers listed inside of there versus the brackets. So the 10, 12 inside curly braces is a completely different set than the 10, 12 inside of parentheses or square brackets as far as what is actually included in that set. So that's combining sets.